Hey, what's up, guys? What's going on, man? We are back for another video, Unit 1.2, adding, subtracting, and multiplying complex numbers. Man, hey, make sure if you like it, man, go ahead, subscribe, so you can stay up to date with all the videos that I'm going to upload. Watch it again, and make sure you are checking the problems. All right, making sure your math is correct. Okay, not just copying, but checking the problems, making sure your math is correct. All right, let's go ahead and get started. All right, man, our standard, guys, you want to know there's complex numbers with I, such that I squared equals -1. All right, and the main focus here, guys, is we want to, the I can statement, identify and solve both the real and imaginary parts of complex numbers. Also, you want to make sure that you can use the relation I squared equals -1. All right, when necessary to add, subtract, or multiply complex numbers. Okay. So let's talk about, first of all, the definition of a complex number. Guys, a complex number is a number that can be written in the form a plus bi. All right, a plus bi. A plus bi is always our where a and b are real numbers, all right, and I equals -1. All right, now look, square root of -1. Now make sure you understand this is standard form, a plus bi. All right, that's standard form. All right, this is the real part. A is the real part, like it's identified here. The imaginary part has the I attached, guys. All right, so bi will always be your imaginary part. If you look right here at our little table, it breaks down real and imaginary numbers right here. All right, if you look real numbers, all right, they're numbers that you're used to working with. Even pi, all right, that's a number. All right, it's 3.14, blah blah blah. All right, these are real numbers. The imaginary numbers all have I in common, guys. I is actually right here as well. You don't see it written out, but remember, if we factor out the -1, all right, you get the square root of 7 times the square root of -1, which is really the square root of 7i. All right, the I is right there. Remember, that is I. Okay, so that is an imaginary number as well. Now, let's go ahead and look at a couple of examples. This first example here talks about equating two complex numbers. It says find the real values x and y to make this equation 4x plus 10i equal 2 minus 4yi true. All right. Now, the first thing I want to point out to you guys is this. Find the real parts. All right, the real parts, the real numbers. For x is a variable, so that's going to be a real part. All right, 4x is a real part, and 2 is a real part. All right, even if this was written out of order, guys, let's say it wasn't written in standard form. Let's say it was written like 4x plus 10i equals -4yi plus 2, right? You still can look at it and go, what's the real part? This is a real part. This is a real part. How you know they're real is, again, because look, the imaginary parts always have I. All right, always have I. Okay, that's imaginary. That's imaginary. So everything else has to be real. Okay, so to solve this, you would set the real parts equal. Right, set the real parts equal to each other. 4x equal to 2, and then solve. Right, so right here you would divide by 4 on both sides. All right, and you get the 4's will cancel, and you're left with x equals 1/2. Right, 2 over 4 is 1/2. Over here, you will set the imaginary parts equal to each other and solve for y. All right, so look, over here I'm solving for y. So I'm going to divide by 4i. Remember, we're solving for y, so isolate the y. Divide by 4 and the I. Again, divide by 4 and the I. Now, over here, the 4 and the I cancel. Right here, the I's are going to cancel. And now I have 10 over 4. Although those are both divisible by 2, so we end up with y equaling 10 divided by 2 is 5, and 4 divided by 2 is 2. So y equals 5/2. All right, so the x and y values to make this equation true would mean x has to be 1/2 and y would need to be 5 halves, okay? Right here, this example, find the values of x and y and make the equation true. All right. The real parts. All right. What would the real parts be? Ask yourself. Well, we know negative 6i is imaginary and 20yi is imaginary. So the real parts are 2z and negative 8. So I'm going to set them equal to each other. And I'm going to set the imaginary parts equal to each other. All right. The one thing I want to point out is don't forget that that's a negative 6i. Okay. That's a negative 8. All right. I don't want you to forget those signs. Okay. Now, anyway, solve for the variable z. All right. Well, it says x and y here, but in this case, the variables are z and y. So solve for the variables of z. Divide by 2 on both sides. All right. Cancel. So 2 equals, z equals negative 8 divided by 4. 2 is negative 4. All right, so there's the first real part. And then the imaginary part, we are going to divide by, or we're solving for y, so divide by 20i. It's 20i. All right, and then you have negative 6i over 20i. All right, we're going to reduce that. So y equals, they both are divisible by 2. So I have negative 3 over 10. All right. Don't forget, guys, those i's are going to cancel. All right. The i's cancel on both sides. All right. Now, there's a you try right here, guys. I'm going to leave that for you guys to try, obviously. All right. Give those a try. All right. Give those a try. Now, the sum of complex numbers, a plus bi and c plus di equal real parts. See, a and b are real. All right, A and B are real. This right here, we're solving for those parts. Here, we're going to add the complex numbers. So A and C are the real parts, BI and C and DI are the imaginary parts. So you add the real parts and you add the imaginary parts. All right. The difference would be the opposite. Well, the difference is the same as that thing in the sense that you're going to solve. Well, first you distribute that negative. All right, don't forget to distribute the negative, okay? Once you distribute the negative, you have the real parts and the imaginary parts, all right? And you would just do the operation sign from there, all right? Complex numbers also have an additive inverse. All right, additive inverse of a plus bi is negative a plus bi, all right? Or negative a minus bi. Again, that's distributing the negative. See that? Distribute that, that becomes negative a. Distribute that, that becomes negative bi. Distribute the negative, okay? So take a look at this first one. All right, we're going to add or subtract. All right, and the results are going to be in the form a plus bi, which is the standard form for complex numbers. So the real parts, we're going to add the real parts. So the real parts are 4 and negative 6. So I'm going to go 4 minus 6. All right, that's going to be my a part, and then my b part is going to be 2i plus negative 7. Negative 7i. Okay. So now for my real part, I have 4 minus 6, negative 2. And over here for my imaginary part, I have 2 plus a negative 7. But guys, it's really 2 minus 7. All right, which is going to be a negative 5i. All right, remember the I, you treat it like a variable here. It stays, okay? 5i. So again, this is in our a plus, or in this case, a minus bi form. All right. But anyway, this is the solution. Okay. That's the solution. So now, one more. We got one more. This one is a minus. So over here, we're going to go, first of all, distribute the negative, guys. All right, so we have 5 minus 2i. The negative and the negative becomes a positive 2. And the negative and the negative becomes a positive 3i. So now evaluate this for real with real and imaginary with imaginary. All right, so 5 plus 2, 7. Negative 2i plus 3i is 1i. All right, so you can put positive 1i, or you can simplify it, go 7 plus I. All right, 7 plus I. So that's how you add and subtract, guys, complex numbers. There are 4 you tries right here. You guys give that a shot, okay? This one and this one, they're not tricky. All right, they look different, but they're not tricky. Up here, a hint is when you look at this one, you see the -3. That's the only real part. So the answer will contain -3. It's -3 plus 0. You can look at this side as if you have a plus bi, this side would be 0 minus 6i. All right, so it's just 0, -3 plus 0. So that's part of the answer. This is part of the answer. This is a hint, okay? A hint. And then you will still evaluate the imaginary part. Over here, you have imaginary parts. You're still missing a real part right here. All right, over here, there's no real part. So again, use that same hint for this one. All right, and make sure you distribute your negative here. Distribute your negative. All right, let's see here. You can multiply complex numbers by using the distributive property and treating the imaginary parts as like terms. Simplify it by using the fact that I squared equals -1. All right, so this is the axiom that you must remember. All right, make sure you know this relation, I squared equals -1. So first of all, remember the rules for multiplying two binomials, foiling. All right, first outside, inside, last. All right, first meaning the first two variables. All right, we're going to go x times x, which is x squared. And then outside, meaning x times -4. All right, outside here, let me show you. There we go. Outside would be x times -4, which is -4x. All right, then we're going to do inside. All right, inside meaning 2 and x, which will give me 2x. And then we have last, all right, the last two terms of each binomial. All right, so we have 2 times -4 is -8. All right, now we simplify this. All right, we have x squared -4x plus 2 is a -2x minus 8. All right, so that right there would be our polynomial. All right, for this two binomials if you multiply them. All right, so again, you do the same exact thing with these imaginary complex numbers. All right, now the one thing I want to address is I want you to remember, all right, at all times that I squared equals -1. Okay, that's important. I'm going to show you why. All right, this first example, let me make this a little bigger so we can have plenty of space to write. Oh, it didn't want to do it. Okay, so starting off, here's what we got. All right, right here we just have the distributive property. We have -2i times 2. That's going to be -4i. And then you have -2i times -4i. Now look, -2 times -4 is going to be +8. But I times I, see there's two i's, is going to be I squared. All right. So now we just distributed this monomial times this binomial. All right, so we have -4i plus 8i squared. Okay. Now, the one rule I want to point out is this. Remember, I squared. I squared is -1. So we're going to convert this I squared to -1. So I have -4i plus 8 times -1. All right, again, we're talking about this relation right here. So 8 times -1 is really -8. All right, and we also still have -4i. Now, the last thing I want to point out to you is this. Remember the standard form rule, a plus bi? All right, well, we're going to write this in standard form. Standard form, remember the imaginary part, the -4i will come last. So we have -8 minus 4i. All right, this is in standard form right here, okay? So this is going to be the solution set for number 8. All right, 8 minus 4i, okay? All right, so now let's look at number 9. Number 9, you're going to have to FOIL again, all right? First outside, inside, last. All right, so first we have 3 times 4. All right, 3 times 4 is going to be 12. Then we have 3 times negative I outside. So 3 times negative I is negative 3I. Then you have 6I times 4, which is going to be positive 24I. And you have 6I times negative I, which is going to be negative 6I squared. Now, remember, I squared is negative 1. See, I squared is negative 1. So we have 12 minus, well, here, let's see what we got. We got negative 3I plus 24I. See the like terms? We're going to add those. So negative 3I plus 24I is actually going to be positive 21I. And then I squared is negative 1. So we have negative 6 times negative 1. Now, go ahead and multiply that. That gives you positive 6. So it's 12 plus 21I. Negative 6 times negative 1 is positive 6. And lastly, 12 plus 6. These are like terms. So 12 plus 6 is 18 plus 21I. This is standard form. All right, that's standard form. All right, this one we're going to, again, FOIL. 2 times 2 is 4. 2 times negative I is negative 18I. 9I times 2 is positive 18I. Sorry about that. Positive 18I. And 9I times negative 9I is a negative 81I squared. All right. The thing to remember is I squared is negative 1. That's negative 1. So we have 4 combined like terms, negative 18I plus 18I cancels. And we have negative 81 times negative 1. Well, that's actually positive 81. So 4 plus 81 gives me 85. All right. 85. And lastly, negative 5I times 6I. No foiling here. There's just 2 binomials. So negative 5I times 6I is going to be negative 30I squared. I times I is I squared. We're going to take that I squared and convert that back into negative 1. So you have negative 30 times negative 1, which is positive 30. Okay. Now, there's a U try right here. Again, FOIL. The one hint I want to leave you is this one. This is a binomial squared. When you have a binomial squared, you actually expand it. Think about it. If you had x squared, that's really x times x. All right. X squared is really x times x if you expand it. So we're going to expand this. All right. So this is our x. That's our x. So we will write x times x. Or in this case, 4 minus 5i times 4 minus 5i. All right. You expand it like that. All right. Write it twice. This tells me I have 4 minus 5i twice. All right. So make sure you expand that one. Give that a U try. Okay. Well, that's it, man. That's the video. As always, let me go ahead and give you the answer key to the U tries. For the first set of U try, all right, you should have 0. All right. This is the answer for number 5. This is the answer for number 6 and number 7. All right. And then, and for the last set of U tries, here are the answers. Okay. So I want you to practice those problems. See if you get the same answers that I get for 4 through 7 and 12 through 15. Okay. Try those 8 problems on your own. All right, try to get those answers. Bring me questions to class on Thursday. Make sure you're trying these and keeping them. All right, remember the homework and the classwork quiz is coming up. You can use notes, you can use classwork assignments, and you can use the U-Try problems. If you have them done with the work, All right, I grade the work, not the answer. I grade the work. I know the answer. I want to see your work. If your work is correct, I know you have the right answer, okay? So please, please, please practice these. If you don't get them, that's okay. Come to class tomorrow. Let me look. Let me see where you messed up so I can go, okay, here's how you fix this so we can get your thing corrected, all right? I want you to do well this semester, all right? Bonus, there are no errors in this video. They're all correct. So please, 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 please watch the video. Watch it again if you need to. And good luck. Bring me questions on Thursday, okay?